Hello class, my name's Sam and today I'll be doing a problem I'll be doing a second order system and we're going to be trying to draw the block diagram of this function that you see before you. So to start off, we're just going to rewrite h of s, which h of s equals y of s over x of s. And then we set that equal to our function, which is 1 over s squared plus 3s plus 2. Then for our next step, we're going to go ahead and try and single out our y of s and our x of s. So we're going to multiply the x of s on both sides, and then we're also going to multiply s squared plus 3s plus 2 to both sides. So I'm writing what that would look like now. So then you're going to get y of s times s squared plus 3s plus 2 equals x of s. And so from here, we're going to go ahead and just distribute the y of s into the polynomial. And the reason why we're doing this is because we're trying to know what our terms are, like our y double primes and our y primes. So we need to know what those are. And the only way to find that out is by using like the definition of a derivative. And the definition of a derivative is s times y of s equals y prime. So that's the reason why we're doing this step right here. So since we have s squared times y of s, that would be turned into y double prime plus 3y prime plus 2y equals x. All right, and this right here is our LCCDE, because we have all of our y terms and all of our x terms on the opposite ends of the equal sign. So we have all of our y terms on one side and all of our x terms on the other, and that's what LCCDE is. So from here, we're just trying to single out the y term, and the reason why we're doing this is because we need to know what our output equals, so that way we can make our block diagram equal that. So now we're going to go ahead and get started on drawing our block diagram. So the x represents the input, and we're gonna work our way I work my way to like a little midpoint, and then I do from the y to the midpoint that I made. So I start at the input and then I go to the output. And the only reason why I'm just starting at the input and work my way from the output to my midpoint is because there's only one x term, so there's not going to be too much happening on the input side. So for the input, we have x divided by 2, so that's the reason why I'm doing an amplifier, which will multiply it by 1/2. And it's going to be added by all the other y terms. So now we're just going to draw a line straight to our output, because after that addition that I made, it will equal the output. So from here, we're going to work our way from the output to the addition sign, because we have no more x's in the equation that we derived. So we're working our way from the output, and the first thing you note is everything is in a derivative form, like there's no just y terms. So first we have to derive the first y to get our y prime, and then we'll have to derive it again in order to get the second y term. So we're going to have a derivative function which will turn it into a y prime, and then we're going to take that y prime and put it through an amplifier of -3/2 to get the term that we're looking for. Okay, and then we're going to make another addition sign from that amplifier I made, because it's going to be added to whatever is going to happen to our Y double prime term. So now we're going to go to the Y double prime, and then we're going to run it through another amplifier of -1/2 in order to get our Y double prime term. And so this is like the process that I would work almost every like block diagram problem. If you're doing it first, you always have to start with the transfer function. Then you want to work your way to the LCCDE form. And from there, you want to single out the Y term that you have so that you'll know what your output equals. And then you want to draw a block diagram that mirrors that output. So here where you see my Y primes and my Y double primes and all that, that's just showing you what's happening at that point. So, you know, Y before, it's just a Y before it goes into the D over DS. And then once it goes through that, it turns into a Y prime because it's taking the derivative. Then it goes into another D over DS, which derives it again and makes it a Y double prime. I'm just showing, so it kind of helps to where you don't get confused on what's happening where. And this is the way that I would just work out every block diagram problem. So I hope this video has helped you, and I'll see you again next time.